Hello all. Uh, we'll wait 2 more minutes for others and then we'll start, guys. Hello everyone. Very good morning. Good evening. Sorry for the delay. We'll start the session. Just a minute. So, okay. Sorry guys, not keeping well. So voice will be little low. Okay. So last session, what we have done is we discussed about data sharing implementation. All right. So now the data sharing, what we have done, we created a reader account and then we share the data to them. Right. When you share the table, what they can able to do, they can able to access that particular table, right? Immediately it will be reflected. The same way, the another concept we have called data sampling. We have a data sampling. Before going to data sampling, so let's try to understand what exactly sampling is, why we require the data sampling. If you go to our like the sample tables database, if you observe here in any one of the tables, any one of the schema, if you go to weather schema, observe this one. Here we have around 38 GB of the data. Here we have around 280 GB data. Here we have 1.7 TB, right? And so 1 TB, right? Different like sizes. We have huge volume of the data it is available. Now let's assume any your data analytics team or so data analytics team or your data science team, they want access to the data. They need access to table. When they need access to table and these guys belongs to our team, what we need to do, we need to create a user for them and we have to give access to this specific table. Let's assume when you give access to this specific table for any specific person, right? Any specific user, what they will do, they are going to access this particular table data, right? When they are accessing, if you observe this, here it's around 38 GB and then like a 300 GB of the data nearly. So if you try to access the data from this, especially when you are doing R&D, you are not going to fetch exact data. You are going to do like the select star from table, and then you will give a number of conditions and all those things. When you are doing that, what will happen? Your computation charges will be increased, right? Our computation charges will be increased. For that, to reduce the computation charges, unnecessary billing, and to increase the development fast, the time fast, we have a concept of data sampling implementation. What it will do is, instead of handling the huge volume of the data, we can create a sample data. Sample data is nothing but it can able to contain all the possibilities. For example, let's take this example for better understanding. During pandemic COVID situations, every like healthcare organization, they are trying to release vaccines, right? When they are trying to release the vaccines, how they will, like government organizations, government authorities, how they are going to approve? They will approve sorry, based on sample, right? They need to give a sample. Based on a sample, they are going to verify so whether they have tested properly or not. If every sample whatever they have produced, if it is a valid sample, then they will approve, approve that particular vaccination, right? So that is what they will do. And when they are, like, assume that this is a example, assume when they are producing a sample, they have tested one, like a medical organization, they said that we tested some sample data from
Hello, Dinesh. I can't hear you. I'm not sure about others, but I
done.
can't hear you at all.
Yeah, we couldn't hear you, Dinesh.
uh, let's take it 60, then 90. Let's assume that if you observe this particular one, this particular sample, what is happening here? It is covering all the possibilities, right? This we will call it as a valid sample data, right? Instead of this one, we can consider this is a valid sample data. If they are providing this particular sample data to get the approvals, yes, we have tested all this, so vaccines on this sample data, so they will get the approval. This is a valid sample we can consider. Instead of this, what is happening here? All the probabilities they are covering, right? All the probabilities they are covering, that is valid sample data here. Okay, now let's assume same way. If you talk about the table, see this, if you talk about this particular table, if you want a sample data on this particular table, in this particular table we have around 38 GB of the data. In this, if you wanted to like take a sample, if you give first 10,000 records, first 10,000 records, it's not a valid sample. So this one here we have around millions of records, 90 millions records is there. If you take first 10,000 records only for a testing, that is not a valid, right? And then if you take, for example, last 10,000 records, last, that is also not a valid. If you take in between, in the middle 10,000 records, that is also not a valid sample, right? Then what will be the valid sample? It means it has to cover all the probabilities from each and every data. It has to cover from starting to ending. It has to take all the probabilities. Then only we can consider all the set of data. Then we can consider that as a valid sample. When it is coming to data sampling, when you are taking, especially any analytics team or data science team, they are doing some insights on this table, then they will come up and then they will ask us to, we are going to work on this particular table, so can you provide a sample data for this? Instead of every time, instead of hitting the huge volume of the data, they will work with a sample data. If it works good, if it looks good, then they will produce a query on the huge volume of the data. Let's say for example, here, come to this, some example here. So why the sampling is required? Yeah, development life cycle will be very quick. So why? So we are going to test on the sample data only. When you are doing testing on a sample data, it's a very less volume of the data, and 80% of the accuracy we will get it. It means 80% of the accuracy only. Why we will get? Because if when they are not testing on a complete data, definitely they cannot say that it's 100%. That's why 80% of the accuracy, and it will reduce so development cost. And when any analytics team, so when they are querying a sample data, then they can test their data on the particular sample data. If they get the accuracy whatever they are expected, then they can execute the query on the huge volume of the data. But when it is coming to here, there is two methods. One is so Bernoulli method. Bernoulli method, this we will call it as a row method. Row method. It is going to pick the data based on probability. Based on probability. I will show you that. And another method is sampling method. This also we will call it as a block method. So one is row method, another one is a block method. So this one, it is going to pick the data. So based on micro partitions, from each micro partitions randomly it is going to pick the data, but it is going to cover all the probability. For example, if you wanted to pick the data, so 50% of the data, then you are going to give, when you are creating a sample, we will give that 50%. 50% we are going to mention. If you wanted to pick only 25% of the data from the whole data, you are going to mention 25. So we will see that how we are going to so implement that. So let's say here, this is sampling. So let's take this table. Going to take specific table here. We will take a table from here. This is the table. From this particular table, observe the keyword what we are using, sample, right? And daily 14 total. This is a table name. This is a block method. So I will give the name as daily 14 table block algorithm, or we will call it as a sample, this particular sample. So system method or block method, system or block method. And here if you observe, within the bracket we have mentioned 3. It means 3% probability, 3% probability. If I mention here 100%, then it is going to pick complete data from this particular table. If I mention 50 here, it is going to pick 50% of the data. If I mention 10 here in place of 3, it is going to pick 10% of the data from the huge volume of the, from this complete data. It is going to pick 10% of the data and it will create a new table. See, this what we are doing is here. So creating a transient table in the class database, and then so the table name is this one. From this particular table, from our sample database table, from this particular table. So but when we are picking, we are using, instead of huge all the data, we are picking only 3% of the data by using system method. System is the one method, or we can call it as a block method. And we are mentioning what is the percentage of the data we required. 3% of the data we require, 3% of the probability. And one more thing, if you observe, see this here, seed 82. This seed is nothing but to identify the sampling. So if any, again, if you wanted to pick the same sample data, then we have to mention the seed number as same 82. When you are doing some other R&D on next time, if you need same set of sample data only, then you can mention the same seed number. What will happen is, seed, once you mention whatever the sample data you picked for any like analysis purpose, the same sample data again you wanted to test something, then you can pick the from the directly from the seed itself. This particular seed, so it will, it's a kind of numeric number seed. If you observe, it's a producer some random number. It is going to be bling. Yeah, see this one. This is a integer number in between 0 to this value. In between, sorry, in between this value, you can use any number just to identify that sample. For example, when you are giving any like a sample, blood sample or whatever it may be, they will assign one unique number to the sample, right? Instead of so again, if they wanted to use it, if they wanted to identify that, they can like identify with that particular id, right? The same way here, once the sample is created, the id is created, that we will call it as a seed here, that we will call it as a seed. Once the seed is created, then again and again, if you want to pick the same seed again and again, they can use the same value. Then what will happen next time, when any other the person we wanted to work with the same sample data from the same table, if they mention the seed, almost it is going to pick the nearest data, the almost it is going to pick the same set of data. That's why they will mention seed here if they wanted to remember that particular sample. Now, if you observe here, we are creating a sample data from for this particular table. Here, if you observe, here it's a 38 GB. Once I created, after that, let's observe how much the data it is going to be occupied for this particular new table. It will be 3%. 3% because we mentioned 3 here, right? It will be 3%. Let's create it. What it is telling. Okay, sorry. Let's run this. So it is going to create a new table. So with this particular sample data. And if you want to, for example, if you see the sampling, see this one, if you mention 10%, 10% of the probability it is going to pick. If you mention 20.3, it is going to pick 20.3 the probability, right? If you mention 100, the 100% of the it is going to pick all the data. If you mention, for example, 0, it is not going to sorry, it is not going to pick any of the data here, right? That is how it is going to pick the data from the sampling table. And what it will do, it will create another table with sample data. Instead of running the queries on this particular table, what they can do is they can run the queries on this particular table. Because of the less volume of the data, your computation charges will be very less, and then they can able to like have all the probabilities, all the set of probabilities will be there. They can able to fetch the data. Same way, this is one method, right? Another method is same way. Instead of this, what we are going to mention is when you are creating, that is a row method. That is a row method. For example, if I mention row here, and so with the same table sample here, instead of system, we are going to mention row. This is nothing but a row method. This one is a block method, and then system method, or we can call it as a system method. This is a row method. This one system method, it is going to pick based on our partitions, whatever the partitions it is going to have. Each and every partition randomly, it is, we are not going to choose any data here. It is going to pick only randomly, guys. We don't have any control on that. So just we are mentioning a algorithm. In the back end, some algorithm will run, and then it will pick the data from the each and every partition. This one row method, it is going to pick based on randomly, it is going to pick. If you observe this particular one, it has taken to create 1 minute sorry, 1 minute 28 seconds it has taken, right? It has taken 1 minute 28 seconds, right? And if you observe this one, this this is based on partition. It is will be little fast when creating a sample table. This is a row method. It is going to take little time. So when compared to the partition method, let it run. And this table is created, the total block algorithm. If you observe, let's refresh it. If I see this one, this is the table which it is created. Now observe how much of the data it is occupied here. It is 994 MB, nearly 994 MB. What is the total data in the actual table? This table is around 38 GB, right? In this, it has picked the data like around 994 5 MB. And when you are fetching a queries on this particular table, then what will happen? It is going to obviously, it is going to take very less time instead of running the very long running queries. That is the main advantage of data sampling here. This is, there is two methods. One is a block method, based on partition it is going to pick. Another method is row method. It is going to randomly pick the data from the particular tables. So these are the two things we will use to create any data sampling, specifically when you are working with any huge volume of the data, for the, especially for R&D kind of thing, analytic uh, team, analytics team or data science team. When they requested any data, we will use this instead of directly sharing the data to them, directly giving the access to them. We'll ask them to work on this particular table. That is the main advantage of data sampling here, guys. Okay. let it finish. I see this one, it has finished within 1 minute 28 seconds, and it is taking to little long time when it picked. So based on the row method, this is a partition method. From each partition it is going to pick this one, randomly it is going to pick the data from the row by row basis. That is the only the difference, but most of the time, so we will use the block method if you wanted to create any data sample here. Okay, this is the concept of sampling, guys. What we'll do is we'll stop it here, and next we will discuss about this best practices. Also, I will upload it here. This is the you can go through this documentation. This is the best practice documentation, which already we have discussed. Anyway, we will discuss so one time tomorrow. Meanwhile, just go through this once the whatever the documents it is available here. Just go through that. We will see that one more time. And after that, next session, we will see about materialized view, guys. What are the different types of materialized views is available, and then what are the advantage of that. Okay, so we'll stop it here, guys. Uh, just a minute. Yeah, and any questions here on this particular topic?
Not hi Dinesh, this is Vipin. Not on this topic. In general, I just want to. I may have missed a few few classes here, so I just want to kind of check. There are a few topics which I'm not sure whether we have covered. Want to check if you have planned. For example, search optimization, drivers and connectors, authentication with MFA, SSO, explain plan, data spill, data caching. So and directory, table, and SQL file functions. So have we covered already, or do we have plan for these stuff?
We have a plan for that. We will see that. Yeah.
Okay.
Yeah.
Yeah, Dinesh.
Yeah.
So, have you come across any such scenarios where you pick algorithm between these two? I know the sampling, block sampling, I understand completely, because anyways we I mean under the data is as any updates or anything, the data will be partitioned with this. Based on some certain columns, it will sort and do the part. Store the data into small partitions, right? So based on the partitions available for a table, it will pick the random rows from each partition. So
Correct,
that way sampling, as we see, like between 1 to 100, you have picked every number between the tens or something, like 1 to 10, 10 to 20, something like that. So this way we could pick up the rows if any specific ID columns or any like serial numbers or something in a particular table, then it will pick the sampling properly. I could understand this one. So in which scenarios we actually like pick the other one?
So this one, right? So this,
Correct.
if it is a very small set of data, if you have still we need to create a data sampling, then only we will go with this one, the row based method. Otherwise,
Okay.
huge volume data, then we will go with this one only. So because it is going to take a little longer time. So when compared to this one, that's it.
Okay. So if you, and then the other one you said, if we put some, mention some seed number, specific seed number, if we create using block system. So can we? So if we run both the algorithms, create a samples using this both these samples, can we expect any like similarities or close to
Close to
samples if we use the
exactly.
same seed?
Exactly. The close near to the same set of sample, it is going to pick almost near similar.
Okay.
That's why we will mention a seed.
So okay. Yeah, because we have actually, um, I mean, partitions will be created based on a particular column, right? One or two
Mm.
columns, like,
Yeah,
so that's why we will get the
same
similar
similarity.
data.
Yep.
Okay. Yeah, that's all. Yeah, thank you.
Yeah, thank you. Okay, guys. I'm sorry for that. We will connect tomorrow, guys. Yeah, we'll continue from tomorrow. Thank you all.
Thanks.